lost track of a particularly important burial, how would you go about finding it again? If you're searching an area where you expect to find the remains of multiple individuals, how would you check whether or not you found the individual for whom you were looking? That's what DNA is for. The answer is DNA. That's why we're here. At least, I thought it was when I started this research. This was the situation of Polish scientists in 2004. Amongst over 100 tombs in Frombork Cathedral, most of which don't record the names of their occupants, they searched for one of the most important people in the history of Western science, Nicolaus Copernicus. Nicolaus Copernicus is regarded as the father of modern astronomy, at least by the author of the biography I read, and within the context of Western science and what we refer to as the scientific revolution. He was born on February 19th, 1473 in Torun, which was part of Prussia at the time. There's actually a university named after him there now, which is super cool. Nicolaus Copernicus is the Latinized form of his name. He was the youngest of 4 siblings, and after his father died when Nicholas was about 10 years old, Nicholas's uncle Lucas stepped in to help provide for the family. Uncle Lucas had the incredibly fancy title of Prince Bishop, and he made sure that Nicolaus and his brother received a good education. Nicolaus started university in 1491, age 19, and then spent 12 years studying before he finished school. I'm not going to pause here and think about how long I've been in university. We are not going to go there. Copernicus studied various different subjects during his time in university. He started studying astronomy and astrology at the University of Kraków in 1491, and he became the assistant to an astronomy professor at the University of Bologna in the late 1490s. He spent 2 years studying medicine at the University of Padua, and he would actually practice medicine for the rest of his life. In 1503, Copernicus finished his doctorate in canon law at the University of Ferrara and returned to Poland, where he would work as an assistant to his uncle Lucas for several years. In 1510, Copernicus became a canon at the cathedral in Frombork. This isn't the same thing as being a priest, and he performed various jobs within this role. His time spent studying medicine in Padua meant that he actually served as the chapel's doctor. Between 1503 and 1513, Copernicus developed his heliocentric theory, his model of the universe with the solar system's planets revolving around the sun. This theory wasn't exactly brand new. The geocentric model, with everything revolving around the Earth, was based on the work of Aristotle and Claudius Ptolemy, but this idea had been questioned by people as early as Aristotle's contemporary Aristarchus. What Copernicus did was present the heliocentric model and data that supported it in a much more comprehensive way and eventually published it. He did a lot of math, and he wrote about it because he was a big nerd. Copernicus worked on the manuscript for what would become On the Revolutions of the Heavenly Spheres for 2 decades. He hesitated to publish it, though not necessarily because he was afraid of being accused of heresy. The beef between Copernicus and the church during his lifetime came from a local bishop getting really annoyed when Copernicus didn't want to break up with his mistress. As a canon, Copernicus was not supposed to have a mistress. No, Copernicus worried that parts of his theory were wrong or incomplete, and ultimately his work wasn't completely flawless. He did finally publish his work in 1545, shortly before he died at the age of 70. An original manuscript of his book is held in the archives of the University of Kraków, and Nicolaus Copernicus was buried in Frombork Cathedral. Over the next several hundred years, the exact location of Copernicus's resting place within Frombork Cathedral was lost. Napoleon ordered an officer to find the tomb in 1807. He did not succeed. In 2004, Polish scientists started a new search for the tomb. This search focused on the area around the Holy Cross altar because Copernicus was in charge of this altar as part of his duties as canon. The cathedral still operated during the excavation, so the digging had to be stopped repeatedly for regular church services and events, including funerals and weddings, which I just find hilarious. The archaeologists found several skeletons, and some of the remains were commingled, some buried in coffins, some buried only in shrouds. So how would the archaeologists and forensic anthropologists figure out if any of these individuals could be Copernicus? This is the point where the story starts to fall apart. I can't tell you what methods were used in the initial examination of the fragmentary remains that allegedly belonged to Nicolaus Copernicus. I can't tell you because I haven't been able to access the original article published about these remains. A book called The Search for Nicolaus Copernicus's Tomb was published, written by an archaeologist involved with the excavation, but I haven't been able to get a copy of it that I can actually read. Without access to any articles about the skeletal analysis, I don't know how the archaeologists and anthropologists involved estimated that the skeleton they found was a male individual approximately 70 years old at the time of their death. There are a few images of 3D scans of the remains in the DNA analysis paper I read about this individual, and the remains are very fragmentary. There aren't many bones left, and they're arranged in a way that makes it a little hard to determine which bones are actually there. Looking at it drives me a little crazy, and it's not clear to me if those scans are available somewhere for further study, like online somewhere. But whatever methods were used to collect data from these remains would have been based on the bones available. From the bones visible in the images, my guess is that they would use the fragments of the pelvis and the cranium to estimate the individual's biological sex, and maybe cranial sutures to estimate the individual's age at death. This is my little study model of a skull. We call him Magnus. But these salmony pink lines are the cranial sutures. So we have the coronal across here, sagittal across top going down the back, squamosal on the sides here, and then on the back, the lambdoidal suture. My model has some wormian bones going on in that suture. There are several other sutures in the skull where the facial bones meet, but these larger sutures have been used to estimate age in skeletal remains. This method is based on these sutures fusing together over time as an individual gets older. Sometimes sutures will become obliterated, that's how it's described, but that means that the sutures aren't visible anymore. The surface of the skull where that suture had been will be smooth. It'll look like it's kind of been erased and like rubbed out. But yeah, nice smooth bone. Like I said before, I don't know for certain if anthropologists examined cranial sutures to estimate this individual's age. It's a method they could have used based on the skeletal material available to them. One thing they did do with the cranium, which lacks a mandible, is a facial reconstruction. This facial reconstruction includes features observed on the cranium, which were described as a scar over the right eye orbit and a nose fracture. This facial reconstruction was then compared to portraits of Nicolaus Copernicus. The next step from here was DNA analysis. When we're trying to identify someone through DNA, we need samples from the unidentified individual and samples that we can use for a comparison. Those samples could come from family members, people who share a genetic relationship with the person we're trying to find. That's what you'll see if we're trying to find a specific missing person, or in cases like identifying the remains of the Romanovs or Prince Louis Charles of France. So, what about the family of Nicolaus Copernicus? Unfortunately, no family members could be located who could provide DNA samples. This includes the remains of Copernicus's immediate family and any potential living descendants of his immediate family. 2 of his 3 siblings entered the church, like Copernicus, so they weren't really supposed to have children. Attempts to locate the remains of his uncle, Prince Bishop Lucas, were not successful. Another option for a source of DNA is a sample associated with an individual that can be reliably attributed to them. This would be biological material like hair or a blood sample, something that would contain their individual's DNA. This can be pretty tricky for historical individuals, but for Copernicus, potential samples were located in Sweden. Why? The Swedish armies invaded Poland during the mid-17th century, and as a result of this, a book that had once belonged to Copernicus was taken to Sweden. This book was an astronomical reference book, the Calendarium Romanum Magnum by Johannes Stoffler, and it's held by the, I'm really sorry for this pronunciation here, the Gustavianum in Uppsala. Please tell me if I got that wrong, and if I did, please correct me on how to pronounce that. The book contained several hairs within its pages, so it was thought that Copernicus was a likely source of those hairs. Samples for DNA analysis were extracted from 3 of the skeleton's upper molars and 1 of the femurs. Like the studies we discussed about Prince Louis Charles of France, this study sequenced part of the mitochondrial genome called hypervariable region 1 and hypervariable region 2. Quick recap, your mitochondrial DNA is found in the mitochondria of your cells, and you inherit it through your biological mother. Although the DNA from the femur wasn't as well preserved as what was retrieved from the teeth, the identical mitochondrial DNA profiles indicate that the teeth and the femur belong to the same individual. That's important because they were finding commingled remains. In Sweden, 9 hairs were collected from the book that had belonged to Copernicus. Of those 9 hairs, 4 yielded mitochondrial DNA, and of those 4, 2 hairs had DNA profiles that matched the sequences from the skeleton. Those other 2 hairs had sequences that differed both from each other and from the skeleton, so they can be excluded as having come from the same source. The DNA in those hairs didn't amplify very well, so it's thought that they came from other people who had read the book in the past, instead of being the result of modern contamination. DNA from living, modern people will show up in much bigger pieces than ancient DNA fragments, because it hasn't had as much time to start falling apart over time. With the DNA from this individual's femur, teeth, and matching hairs, the scientists found that this individual belonged to mitochondrial haplogroup H. This is one of the most frequent haplogroups seen in European populations. At the time this study was published in 2009, approximately 40% of Europe's population that had had their mitochondrial DNA analyzed like this was classified into this haplogroup. It's uniformly distributed across Europe. This information doesn't necessarily support or refute an identification of this individual as Nicolaus Copernicus without any maternal relatives we can compare the DNA sequences to, but it's a fun little fact to share. The scientists also looked at part of the HERK2 gene, or this individual had a variant of this gene associated with having blue or gray eyes, though paintings depict Copernicus as having dark eyes. Keep that in mind for later. Despite the potential discrepancy with the eye color, the authors of this study concluded that the combination of archaeological, anthropological, and genetic data supported the identity of these remains as being Nicolaus Copernicus. The remains were reburied in Frombork Cathedral, but that's not the end of the story. The confusion over the differences in eye color between Copernicus's portraits and the genotyping of the remains wasn't the only controversy surrounding the excavation of Frombork Cathedral and the identification of these remains. To address this, a bunch of scientists in Poland got together and held a conference about Copernicus, the excavation, and the analysis of the remains. Day 1 of the conference focused on talks from people who were involved with the search for Copernicus's grave and the analysis of the remains, and Day 2 included talks from commentators. They also watched videos and documentary films about the search for the grave. I tried to find some of these videos here on YouTube, but it wasn't terribly successful. The papers presented during this conference were published together as an edited volume from the Polish Academy of Arts and Sciences, titled The Nicolaus Copernicus Grave Mystery, a Dialogue of Experts. Some of these articles are very short summaries of the talks presented at the conference, while others offer new methods for analyzing the data or some more historical background that we need in order to interpret this data. One of the authors pointed out a few things about the excavation that struck me as being especially odd. According to their article, there's no radiocarbon date for these bones and the grave in which they were buried. Radiocarbon dating is used in archaeology so often, I think it's easy to take this method for granted, even when we have a good idea of how old our site is. If radiocarbon dates come back that indicate a site isn't the age we thought it was, that can change our perspective of that site and prompt us to ask different questions. This has actually happened with one of the cemeteries I'm working with in Poland. The oldest of Frombork Cathedral's buildings were constructed between 1329 and 1388, and the cathedral saw use over a span of multiple centuries, so a radiocarbon date might help to narrow down the time period in which the burial took place. There also wasn't any published analysis of stable isotopes involving this individual. This would have been useful for trying to get an idea of where this individual grew up, which could have then been compared to what we know about Copernicus's early life. Multiple authors highlight other gaps or potential problems with the skeletal and DNA analyses. Like I mentioned before, we don't know what methods were used to estimate this individual's age. Maybe the estimation was based on cranial suture closure. Maybe it was based on the rate of wear in the individual's teeth. But we can't know without access to the original studies. When we estimate an individual's age at death from their bones, We can't pinpoint a precise age. We can give an age range, but those ranges get larger for older individuals. There's variation in the rates of growth and deterioration in the bones of different individuals. And age isn't the only thing that can affect the appearance of a skeleton. What about the DNA analysis, particularly the hairs in that book Copernicus owned? We can't really guarantee that those hairs came from Copernicus. While he did own that copy of the Calendarium Romanum Magnum for approximately 20 years, after his death, the book belonged to the group of canons working in and around Frombork for almost 80 years. So other people would have had access to the book, and some of those other people could have also been buried in Frombork Cathedral. There are also alternative interpretations of the observations made on the individual's cranium, particularly the supposed evidence of a nasal fracture, a broken nose, and a scar over the right eye orbit. These are features that were included in the facial reconstruction. The nasal fracture is based on the asymmetry observed in the bones of the face and around the nose. The idea here is that the bones broke, and then they healed in a way that created that asymmetry. However, an author made the point that there are multiple potential ante-mortem, before death, causes of asymmetry in bone, and seeing that in a skull isn't necessarily evidence of the processes of fracture and healing. Potential causes of asymmetry before death include congenital or developmental anomalies, metabolic diseases like rickets, tumors, or muscle activity and damage. Without access to any published articles about that initial skeletal analysis, we can't know if anyone compared the cranium to any skulls with known healed nasal fractures, or even x-rays of broken noses as they heal. This is why comparative collections and reference materials such as photos, x-rays, or 3D scans are so important. What about the potential scar over the right eye orbit? It's a small groove in the frontal bone where your forehead is, but instead of being evidence of an injury, it could be an impression left in the bone by a blood vessel. This is something we can usually see on the inside of the cranial vault, and it could just be the bone adapting to the soft tissue that was around it during an individual's life. Like I've said before, the broken nose and scar were included in the facial reconstruction. There are some issues with this reconstruction and its comparison to portraits of Nicolaus Copernicus, but this is a really great example of why research that's asking questions about the past needs to be interdisciplinary. We need experts in different subjects such as archaeology, human osteology, and art history to add pieces to the puzzle. Some of the portraits used for comparison might not actually depict Copernicus, and none of the portraits were painted during his lifetime. Some are copies of earlier portraits, but it seems that the originals no longer exist, and this includes one portrait that's said to be a self-portrait. This makes it difficult to know how accurate these images might be to what Copernicus really looked like in life. This issue isn't exclusive to Nicolaus Copernicus, and you can find similar discussions about portraits that are said to depict some of the wives of King Henry VIII of England. Facial reconstruction is sometimes used in the context of forensic anthropology if an individual's DNA is too degraded to be used for identification. There are various methods used to create a reconstruction based on a skull, and the reconstruction can be done digitally, as a sketch, or as a three-dimensional sculpture with modeling clay. However, this kind of work does have limitations if you're working from a skull. A skull won't give you the shape of the soft tissue parts of the nose and ears. There's also some discussion of the role of artistic interpretation in facial reconstructions from human remains, and scholars participating in the Copernicus conference did bring this up in relation to the reconstruction that was compared to the portraits of him. The portraits depict Copernicus as a young man. They don't show us a 70-year-old man, which is what we see in the reconstruction from the skull. So it's not clear if this is the most useful comparison. Our faces change a bit as we age. The last thing to note about the facial reconstruction is that it was created by only one team instead of multiple independent teams, but different research groups can produce different results with their reconstructions, so it can get rather subjective. Part of the conference's name is the phrase, a dialogue of experts. At the end of the edited volume, the editor poses a question. Is this dialogue of experts truly possible in this situation? The answer they give is no. because the archaeologist who edited that original book, arguing for the positive identification of Copernicus's remains, didn't participate in this conference. They didn't contribute to the dialogue, and we're still left unable to access the original data. With this story being absolutely the opposite of straightforward, what are we supposed to make of this big mess of information? Of the data we have, the data we're missing, and the critique of the entire investigation? Access to data is ideal so that we can have useful discussions about what that data means. Having other people read your papers and understand what methods you used and how you reached your conclusions is part of the peer review process. And that's a goal of publishing our work anyway. Knowing that an interesting study was done, but not being able to read it, is incredibly frustrating. For something as big as identifying the remains of Nicolaus Copernicus, the lack of data is super weird. One of the papers from the conference describes it as a clear violation of scientific conduct, which is pretty savage. Ultimately, more data would be great. In terms of the DNA analysis, we would be on much more solid ground if we could compare the sequences from the skeleton and the hairs with samples from someone genetically related to Copernicus. His uncle Lucas would have been a good candidate. As his maternal uncle, his mother's brother, the two men would share the same mitochondrial DNA passed down from Copernicus's grandmother. Unfortunately, that comparison was impossible in this case. Was this identification a case of wishful thinking? That can sometimes play a role in the interpretation of archaeological data. It's easy to see the appeal of the announcement of rediscovering the grave of Nicolaus Copernicus, of wanting this individual to be Copernicus. The data we have might not be able to say that the skeleton was Copernicus, but it also can't exclude the possibility that it really is Copernicus. We can also ask if it even matters whether that skeleton was reburied as Copernicus is really him. He's buried in Frombork somewhere. We can say that. I don't really have an answer for that one that doesn't include quoting Captain Picard, so let me know what you think in the comments. Where can you read more? Researching this video turned into an excuse to read a biography of Nicolaus Copernicus, and the one I found was Copernicus's Secret: How the Scientific Revolution Began. All of my references will be listed below, and thank you for watching.